Hi guys, welcome back to our lecture series on probability. In our last lecture we have seen multiplication theorem of probability. Today we are going to discuss about independent events. Independent events. See, those who couldn't watch my previous videos, just try to watch it first before watching this video about independent events. Now let us go directly to independent events. See, in our last lecture we have seen that what is multiplication rule of probability. We have seen that multiplication rule in the case of two events is P of A intersection B is equal to, it is P of A into P of B given A. P of A intersection B is simply means probability of happening both the events A and B. It is probability of happening the event A into probability of happening the event B if the event A has already happened. And this we have seen in our last lecture on multiplication theorem. So today let us discuss about conditional probability, independent events. Now let us assume that P of A given B is equal to P of A and P of B given A is equal to P of B. Let us assume that P of A given B is nothing but P of A and P of B given A is equal to P of B. Then what actually is meant by this? See, P of A given B, what is the meaning of P of A given B? It is the probability of happening the event A if the event B has already happened. So P of A given B is, it is the probability of happening the event A if the event B has already happened. And that is equal to the probability of happening the event A itself. Then what does it mean? So here no condition is given. It is simply probability of happening the event A itself. But here it is probability of happening the event A if the event B has already happened. And that is equal to probability of happening the event A itself. Then from here we can easily understand that the occurrence or non-occurrence of the event B does not affect the probability of occurrence of the event A. Is it clear? And in this case, what is the meaning? P of B given A is equal to P of B. What is P of B given A? It is probability of happening the event B if the event A has already happened. That is equal to probability of happening the event B itself. That means occurrence or non-occurrence of the event A does not affect the probability of occurrence of the event B. Then these two events are said to be independent events. Independent events. Independent events. So if A and B are independent events, what is the condition? P of A given B will be equal to P of A and P of B given A is equal to P of B. So if two events are independent, then what does it mean? If two events are independent, occurrence or non-occurrence of one of the events does not affect the probability of occurrence of the other. Here, occurrence or non-occurrence of the event B does not affect the probability of occurrence of the event A. Here, occurrence or non-occurrence of the event A does not affect the probability of occurrence of the event B. So combining these two, we can say that the events are said to be independent if the occurrence or non-occurrence of one of the events does not affect the probability of occurrence of the other. See, and also we have seen that P of A intersection B is equal to P of A into P of B given A. So if A and B are independent, if A and B are independent, what will be P of A intersection B? P of A intersection B. We are using this rule, and this rule is nothing but multiplication rule that we have seen in our last lecture. So P of A intersection B is equal to P of A into P of B given A. So P of A intersection B is equal to P of A into, if A and B are independent, what is P of B given A? P of B given A is P of B itself. So P of B given A, P of A intersection B is equal to P of A into B given A. But if A and B are independent, P of B given A is P of B. So it is P of A into P of B. So this is the condition for the two events A and B to be independent. So what is the condition for the two events to be independent? If two events A and B are independent, then P of A intersection B will be P of A into P of B. Otherwise they are called dependent events. Right? You see, if this condition is not satisfied, they are called dependent events. So if A and B are independent, then what is the condition? P of A intersection B is equal to P of A into P of B. Now let us consider three events A, B and C. A, B and C are independent if, what are the conditions? P of A intersection B is equal to P of A into P of B, and second, P of B intersection C is equal to P of B into P of C, and P of A intersection C is equal to P of A into P of C, and P of A intersection B intersection C is equal to P of A into P of B into P of C. That is what is meant by independent events. Now I think the concept of independent events is quite clear to you. So what is meant by independent events? If A and B are independent, if P of A intersection B is equal to P of A into P of B. If A, B and C are independent, what are the conditions? P of A intersection B is equal to P of A into P of B. P of B intersection C is equal to P of B into P of C. P of A intersection C is equal to P of A into P of C, and finally P of A intersection B intersection C will be equal to P of A into P of B into P of C. These are the conditions for three events A, B and C to be independent. So what is the meaning of independent events? See, two events, for the sake of simplicity, let us consider two events. So two events A and B are said to be independent if occurrence or non-occurrence of one of the events does not affect the probability of occurrence of the other. So two events A and B are said to be independent if P of A given B is equal to P of A and P of B given A is equal to P of B. So what is the meaning of P of A given B? It is probability of happening the event A if the event B has already happened, and that is equal to probability of happening the event A itself. That means occurrence or non-occurrence of the event B does not affect the probability of occurrence of the event A. Or generally speaking, we can say that two events are said to be independent if occurrence or non-occurrence of one of the events does not affect the probability of occurrence of the other event. Now, so you must understand these conditions. So two events A and B are said to be independent if P of A intersection B is P of A into P of B. What is the meaning of P of A intersection B? It is the probability of happening both the events A and B. If probability of happening both the events A and B is equal to P of A into P of B, then the events A and B are independent. So we have seen the conditions for three events A, B and C to be independent. Now let us see a very simple problem. See, let us consider the random experiment of drawing a card from a pack of cards. We are considering two events A and B. So what is the random experiment here? The random experiment is the event of drawing a card from a pack of cards. A is the event of drawing an ace card and B is the event of drawing a spade card. A is the event of drawing an ace and B is the event of drawing a spade card. Now, the question is, we have to check whether A and B are independent or not. So how will you check whether A and B are independent or not? If A and B are independent, we know that P of A intersection B will be P of A into P of B. So what is P of A here? P of A. It is the probability of drawing an ace card. Right. What is the probability of drawing an ace card? In a total of 52 cards, how many ace cards are there? 4 ace cards are there. Then P of A means probability of drawing an ace card is 4 by 52. And what is P of B? It is the probability of happening the event B, probability of drawing a spade card. Right. So what is the probability of drawing a spade card? In a card of 52, how many are spades? 13 are spades. See, I think you are well aware about the suits and the number of cards in each suit, etc. So, P of A is equal to 4 by 52 and P of B is 13 by 52. What is P of A intersection B? See, what is the meaning of P of A intersection B? P of A intersection B means probability of happening both the events A and B. Both the events A and B means what is the probability of drawing a card which are both ace and spade. Is it clear? What is the meaning of P of A intersection B? It is simply probability of happening both the events A and B. Here both the events A and B should be happen simultaneously. So both the events A and B should be happened. That means the card drawn should be an ace as well as spade, or the card selected should be an ace of spade. Isn't it? P of A intersection B simply means probability of drawing an ace of spade. That means these two events should happen simultaneously. So P of A intersection B means probability of happening both the events A and B. That means probability of drawing a card which are both ace and spade, or probability of drawing an ace of spade. What is the probability of drawing an ace of spade? What is the probability of drawing an ace of spade? See, in spade only one ace is there. So it is 1 by 52. What is the total number of cards which are both ace and spade? It is only one. Only one card is there, which is both ace and spade. That is, that card is the ace of spade. So one is the total number of cards divided by total number of cards is 52. So P of A intersection B is equal to 1 by 52. What is P of A into P of B? P of A into P of B is equal to 4 by 52 into 13 by 52. So 4 by 52 into 13 by 52. So we can cancel this 4 and 52. We will get 13, and this 13 and 13 can be cancelled. We will get 1 by 52. So here P of A intersection B is equal to 1 by 52, and P of A into P of B is also 1 by 52. So here we can say that P of A intersection B is equal to P of A into P of B. P of A intersection B is equal to P of A into P of B. So what is P of A intersection B? It is 1 by 52. What is P of A into P of B? That also is 1 by 52. So here P of A intersection B is equal to P of A into P of B. Therefore, A and B are independent. Therefore, A and B are independent events. So what do you mean by independent events? Two events are said to be independent if the occurrence or non-occurrence of one of the events does not affect the probability of occurrence of the other. So two events A and B are said to be independent if P of A intersection B independent or not. For that, P of A, it is probability of drawing an ace card. How many ace cards are there? 4 ace cards there. 4 ace cards are there in a pack of 52 cards. 4 so 4 by 52. What is P of B? Probability of drawing a spade card. It is total number of spade cards by total number of cards, 13 by 42. And what will be P of A into P of B? 4 by 52 into 13 by 52. 4 by 52 into 13 by 52. This 4 and 52 can be cancelled. You will get 13. And this 13 can be cancelled. So this is 1 by 52. And what is P of A intersection B? What is the meaning of P of A intersection B? It is probability of happening both the events A and B. Probability of happening both the events A and B means these two events should happen simultaneously, or the card drawn should be both ace and spade, or in other words, the card drawn should be an ace of spade. If an ace of spade is obtained, we can say that the event A and B has happened, isn't it? So, what is the probability of drawing both ace and spade? It is the probability of drawing an ace of spade. Only one such card is available, divided by total number of cards is 52. So P of A intersection B 1 by 52. P of A into P of B is also 1 by 52. Therefore P of A intersection B is equal to P of A into P of B. Therefore A and B are independent. Now I think independent events is quite clear to you. Okay, in our next video we will discuss some other topic on